So an Armstrong number is a number which let me share it with you what I mean by that. So let me open the paint screen, and so in looping these are good exercises to solve. Okay, the number 153. Okay, if I take the individual digits, what are they? Then I take the cube of each of them. So what is 1 cube? 1 cube is 1, right? Then what is 5 cube? And then what is 3 cube? And now you add them together. What do you get? Yes, you get the number itself. You get the itself. So that is, so 153 can be thought of as a Armstrong number. So the number whose individual digits cubes, the summation of the digit cubes, you can say the summation of the cubes of individual digits form the very number. Such a number is called as. Okay. Next Armstrong number is 370. So how will we check that? The individual digits are 7 and 0. 3 cube 27, 7 cube 343, and 0 cube 0 gives you, right? Next number is 371. Next number is 407. So like this, you have to accept a number from user and check whether it is Armstrong or not. Okay. Before moving on to that, let's take a simpler assignment. You take a number from user and you find me the sum of digits of that number. Can you do that? Sum of digits of that number. So if you have taken number 1, 2, 3. So what are the sum of digits of 1, 2, 3? I want the output as 6. How do we do that? So what algorithm will you follow? What step by step? So algorithm means step by step approach. Okay. So first you will say I will start. Then second I will accept a number and store it in n variable. Accept a number and store in variable n. Okay. Now what to do? Next what to do? So how will you separate them? So from 123 what will you extract? From 123 what will you extract? So which digit will you extract first? So which number would you want to extract first? 1. So do you have any machine which can extract the first digit of a number? Remember I taught you two machines in programming? Remember? The two machines are mod 10 and divide by 10. Do you recollect? So what does mod 10 give you? It gives you the last digit of a number. Remainder, mod gives you remainder. So even if you do with mod 2 or mod 3 or mod 4, they all will give you remainder. What is so special about mod 10? Last digit. So if I add 1 plus 2 plus 3, is it not same as 3 plus 2 plus 1? So instead of extracting 1, if I extract 3, will it change the answer? So do we have any tool to extract the first digit? But do we have a machine to extract the last digit, right? So why not use this machine? So so now in my n, what value do I have? I'll take one more variable called as the sum and initialize it to 0. Okay? Initialize sum equal to what? 0. So what does the variable sum have? Sum has 0. Current it is 0. So you should know what is the value in each variable in each iteration. Now is 123. Now this 123 I will keep on reducing. I will make it 12, I'll make it 1, and then I'll make it 0. Okay? This will reduce. So I will pass this through which machine also? Mod and divide as well. What does a divide machine do? If I pass 1, 2, 3 with mod 10, what will it give me? And if I pass 1, 2, 3 with divide by 10, what will it give me? 1, 2. So I will pass it. So which machine will reduce the number? Divide. So I will pass this with through both the machines. Okay, so you can say we will line up the machine one after the other. So you can think of this algorithm that we are applying this logic. So this number will pass through both the machines. First it will pass to the mod 10. So whatever output I will get, okay, whatever output I will get, I will collect it in a variable called R. Which variable? So whatever output of this machine, I will collect in which variable? The output of this machine will come in the variable called R, that is remainder. Okay. Once I have got the R, then what do I do? I pass this number to which machine? Divide by 10 machine also. So what will that give me then? That will give me 12. And now I want a finer number. You know what is fine? So when you go to, make that wheat flour, so it has a coarse flour also, and then you have a very fine grained also, right? So what I will do is, now I have got 12, I want it even more finer, so I will recycle it. What will I do? Yeah, try to understand this concept, what I'm trying to do. What I will do is, I will recycle it back so that I can get a more finer. Okay, so I will send it back over here. I will send it back. I will send it back. So what am I sending back now? What am I sending back? 12. Is 12 greater than 0? So first what was there in R? So now currently in R we have 3, right? Now again, now I'll pass 12 to mod 10. What will it give me? 2. And I will keep on adding this to the sum. So what I will do is my final collection in which I will be storing is my sum. Okay. So I will dump all of this into the sum. So first what was in sum? 0. Then whatever returned by mod by 10, I added that to sum. So sum became 3, and just copy paste, right? 3 was in both. So 3 was in R also and 3 was in sum also. So in sum I got 3. Now, now 3 has done its job. So I pass it through this divide by 10. I get 12, right? So from here I will get 12. So I pass this 12 to which again for final. So it goes over here, and what is 12 mod 10? 2. So what 2 comes in which variable? R. Then I dump it in sum. Sum plus R, what does become? Sum becomes 5. So now 2 also has done its job. And now I pass 12 through which machine? So what does it give me? 1. Okay. So now this 12 will be 1. And now this 1 will go on from the top. Is 1 greater than 0? So what is the last digit of 1? 1. So 1 will come in R. Sum the R. So what will it become? What is sum will become? 6. And now if I pass 1 through with the divide, what will it give me? 0. And now when I pass 0, is now is 0 greater than 10? Is so here you will keep on checking whatever when before passing you will check whether it is greater than 0. Is 123 greater than 0? I pass. Is 12 greater than 0? I pass. Is 1 greater than 0? I pass. Is 0 greater than 0? I will not pass, and I will break the loop, and I will display directly. What will I display? Sum. Okay. So here we had true. So the machines were operated. Here also we had true. So machines were operated. Here also I had true, machines were operated. But here in the final stage we have false. So the machine will not work and loop will break. You got this? So here what will we do? Step 4 is n greater than 0. Okay. Then go to step 5. Which 5? Which step? Okay. And if no, else go to the step which will display the sum. I'll just wait for which step that is. So now what will step 5 do? R equals to n mod with 10. And what is step 6 doing now? Sum equals to R. And what is step 7 doing? N equals to 10 by 10. Okay. And this is your loop. Step 5, 6, 7 is your loop, right? So let's keep it as one single step only. Okay. And steps 6 is display sum, and 7 is stop, right? And if else, go to step 6, right? So if n is greater than 0, go to step greater than 0. So what will phi do? What will phi do? First extract the r, add the r to the sum, and reduce the. Okay. and once everything, this 5 will keep on doing, and once n is less than 0, it will go to step 6 and loop will break, right? So this is called as algorithm. What is this called as? And then you also have a flow chart. Okay, so in your software engineering, so algorithm and flow chart is a pictorial depiction of the algorithm. What is flow chart? Yeah, so if this is my algorithm, so the flow chart will just display it in the form of pictures. So how it displays that? So your rounded rectangle is called as start, okay? And parallelograms mean input. What does parallelogram mean? This is a rectangle, right? This is for the processing part. Whenever you're doing input output, you will just take a parallelogram. So something of this nature it will look. Okay, so it will look something of this nature. Right? The input and output will be in this parallelogram. So what will you say? Except n, okay? And then except n, initialize sum to initialize sum equals to 0. And then what will you check? So check means diamond, condition means diamond. Okay, so you should, when you do a project later on, no, in your final year you will be asked to do a project and submit some reports, some paper publications. So those publications will ask you to show the methodology. So all that you have to show them in the proper algorithm and flow chart. So this is the condition. What is the condition? Is n greater than 0. If yes, what to do? If yes, what to do? Then we have to do this step number 5. The step number, we'll have to do the step number 5. So we'll have to do this. You can just copy paste this and put it over there. So if it is there, then do this, right? And then again go back, right? Then again go back to the condition checking. So it's a loop, right? And once it becomes false, so it will come here, and then we will go and display it. Yes or no? If it becomes false, then we will display, and display also is the input output. So will also be in a parallelogram. So wherever there will be input output will always be in parallel. So input also and output also. So displaying also is an output, right? Display also is an output. So we will just say like this: display the sum. And then you will stop. So flowchart is just the pictorial depiction. Display sum. Now will we write stop? Rounded rectangle. So start and stop will come as. Here also we had rounded rectangle. Start. And here also we will have a rounded rectangle stop. And the arrow lines are very important. Arrowheads are very important in a flow chart. So like this you have to. So algorithm, 4 things. Whenever you are doing programming, you have to keep in mind 4 things. First the algorithm, second the flow chart, third the code, and fourth the dry run. So here we have done the algorithm, flow chart. Now let's write the code. Okay. So how will the code look like? Let's write it over here only. so that we have everything in one place. So in one frame we can put entire stuff. So what will we write? Printf, printf, enter number, and then you will scanf and put it into n. Percentage d and n. And what will you say? Sum equals to 0. We'll declare them on the top, okay? We'll declare them on the top. Integer n comma sum. So we will also require r also. Yeah. What will we say? While my n is greater than 0, come inside. No, 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 not required. R equals to not n mod 10 sum plus equal to r divide equal to 10. Okay. The loop finishes. We will print a okay, percentage d comma. Making sense? Okay, so this is the code. So I copy this code and let's try to run it. Okay, so you able to see my screen? Okay, so let's try to paste that code over here. Okay, so PF will not work. We'll have to write printf. We'll have to write scanf. We'll have to write printf. Rest all look to me. Let's run it. Enter number 123 and you got 6. Okay. What if I want to calculate the number of digits in a number? How many digits are there in 123? You just use the R. Like, so if I ask you to share, if I share this code with you and ask you to do that, can you do it? On the chat I am sharing it with you. Yeah. So I want now you to define this code and count me the, yes, you are the host. Okay? Count the number of digits in a number. So if I give you 123, what will you say? If I give you 1 2, then if I give you 1 2, and if I give you 7 7 7 7 4 times 7, then yeah, come on. Yeah. Yes. Now just fine tune this to count the number of digits. Yeah. See, if I have 100 rupees, three notes in my pocket, how much money do I have? How much money do I have? And how many notes do I have? How much money do I have? If I have 100 rupees, three notes in my pocket, how much money do I have? And how many notes do I have? So if you want to take the sum, you take the sum variable. And if you want to count, you take the count variable. So replace the sum with counter first thing. So this is the thing. So you show depending on the task, your counter, keep it counter. Or you can keep it digit counter. The variable name should make sense. So people when they just read the variable, they should like okay, this is a count. Yeah, so now our counter is 0. Now what will you do? Now the number of times the loop runs, those many digits I have. So now line number 11, 12, 13, delete it. No, just delete line number 11, 12, sorry. And in that, just increment the counter plus plus. Because the number of time the loop runs, no, keep this. Keep 12, yeah. Line number 11. Just at line number 11, write counter plus plus. Plus plus. Plus. One more. Increment variable. Yeah, so now the number of time this loop runs, that's the time the counter will increment. So if you are given number as 12, so now open the Excel sheet besides it. Let's do a dry run. So algorithm, flowchart, code and dry run. Four things we have to master. So now let's take the number as 777. Or let's say the number as 456. So 456 will come in which variable? You have taken n. See, your dry run should match with your code. Your code you have taken n. Say take the same variable. Yeah, so n counter. No need for r over here. Remove the r variable. Yeah, when the variable not required, you can delete it. Yeah. Now go back to the Excel sheet. Yeah. Now n is 456. Okay. So now and counter is 0. Yeah. Select both of these two columns. No, there's no yeah condition. Select these three columns and condition. What is the condition? Is you'll read as while as is n as 456. Yeah. Yes, is 456 greater than 0. So don't write n. In the dry run, write the variable value. Is 456 greater than 0? You will say yes. So true. You'll come inside and what are you doing? You're just incrementing the counter. Counter becomes 1. And now n becomes 45. It goes up again. Is 45 greater than 0? You will say true. True. And you will come inside and counter increment. Counter becomes 2. And n becomes 4. Is 4 greater than 0? True. And counter again becomes 3 and 0. Is 0 greater than 0? False. And the loop will terminate. And what will you display outside? Display the counter, right? So now you are displaying sum. So change that to counter. Line number 14. Line number 14. Yeah, now run the code, copy paste it. Okay, got it. Okay. Now I want you to display me the count of only odd digits. So which are the odd digits? Is four is no no is four odd or even? Four is even, not the position, the number. Is four odd or even? No no no. Is four odd or even number? So if I now this number, this 453 has how many digits? Number 456 has how many digits? Out of these three digits, how many digits are odd and how many digits are even? Yes, very good. So initialize them. Yeah, so initialize them. No, odd counter, even counter. Don't give generic names. Yeah. Hmm. Hmm. Initialize go to zero now. Zero. You can do it on the same line. Uh, Aryan. Do odd counter equal to, do after odd counter equal to number 8. No, line number 8. No, 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 not that. Line number 8. Yeah, and then add only one zero. And yeah, this one. This also you can do it. So now once both are zero, now what to do? Now you have to check. Yeah, what condition will you apply? So where is the digit? We have not taken the digit here. The digit is by mod 10, right? So you require R over here again now. So take the comma R, and at line number 10 hit enter. R equals to n mod 10. R equals to n mod 10, and now semicolon, if R mod 2 equals to 0, meaning it's a even number, equal to 0. Yeah, so even counter plus plus. Else our odd counter plus plus. Yeah, remove the counter at line number 18, delete line number 18, and now come outside and display even digits are odd counter, number of odd digits are odd counter. Give a slash n at both line 20 and 21. Give a slash n at line number 20 and 21. So that they come on. Yeah, the start, yes. Okay, so now what we are doing is taking each number and checking whether it is odd or even, and depending on that, we are incrementing the counters, respective counter. Any number you want to. Even digits are and odd digits are 1, right? Now if I want to find the sum of all even and sum of all odd, then we want 4 plus 6 and 5. Yeah, so I want sum of even digits is 10 and sum of odd digits is 5, if this is the input you are giving.
Sorry, sir, we were here, right? So we are now we have to display 4 plus 5 and sorry 4 plus 6 and
Yeah.
5.
Yes, we want to do that. I want you to display me the sum of all odd and sum of all even. So what we will do over here is first, as you are doing sum, not counter, change the variable names to sum counter and even counter and odd counter. So make it odd sum and even sum. So
We'll keep odd and even counter.
no, odd sum. Now we are not counting, right? Now we are doing summation. So odd sum and even sum. Okay. So initialize both. Yeah, both of them to 0. And okay, now while your n is greater than 0, you first you bought the r. Now what will you do once the r is r what to equal to 0, means the number is, so you'll add that r to the even sum. So even sum plus equal to r, and similarly if it is not even, it is odd, you will add it to the
Yes.
r, and then you will display sum of all odd numbers is and sum of all even numbers is. Yes, now if you enter the number 456, it should give you sum of even digits are 10 and odd digits is 5. Line number 7, there is some problem in line number. Okay, you written main twice. So delete, do a control, yeah, delete 3 and 4. Yeah, makes sense. Okay. So which digits are more in this? Odd digits are more or even digits are more? The sum, the sum of which digits are more? Even digits sum is more or odd digit sum is more? So I want you to display it as an even biased number. No, some teachers are biased to some students, favorism. So this number is biased towards which side? And if yeah, after this, after the loop, once I get the sum total, yeah. So yes, no. So you can put it after the line number 23. First display all the digits and then put that whether it is even or odd. So you can come at line number 23 and end of 23, hit enter. Now also you can say. So now if so it is you have three categories of numbers: even biased, odd bias, or neutral number. What will you say? So see, switch case. How will you? What cases will you have then? Because this is a range number. So you have three options, right? Either it can be neutral number, odd biased, or even biased. So if if the even sum equal to odd sum, neutral number, neutral number. No, two equal to, yes. Comparison is two equal to. Single equal to is assignment. If you give one bracket, so it will take the second bracket on its own. Okay, okay. Print neutral number slash n. Put on a new line. Slash n. Put it on a neutral on a on a different line. Copy line number 25 to 27. No, just change the operator and just change the print statement. Yeah, after the else, copy this and paste after the else. Just paste after the else. Yeah, change the operator. If it is equal to greater, then it is even biased. So if it is neither, and now at the end just give a else. So if it is not equal nor, yeah, just give a else over here. Else will not have a condition. Else will just have a, remove the condition. Else will not have a condition. It is a biased. On biased. Yeah, now run the code. It's a even biased, right? And enter 1143. So digits are 4, even also are 4. It is a neutral bias. Okay. Very good. Now, based on this same phenomena, we have to do what is the Armstrong number. Okay. So let's move to your VS code, please. Yeah. So uh, take just take See, once we take the number 153, that number will evaporate because 153 will become 15, then it will become 1, and then it will evaporate to 0, right? And we also want to compare it at the end. So what will we do is, at line number 8, remove line number 8, delete that. As of now, delete it. So take a, and at line number 5, take a variable called temp or backup, whatever number you want. Take it variable called backup. Yeah. And whatever n you get, you first take a backup of that n. So after line number 7, hit enter and store the n in the backup. So what is in backup now? So if n is 153, what is in backup? If n is 153, what is in backup?
Computers are 153.
Okay.
Whatever changes we have to do,
Compare it with backup. Okay. Now take sum also. At line number 5, declare a variable sum. Line number 5, declare a variable by the name sum and initialize it to 0 on line number 8. After line number 8, initialize it to 0. Yeah. So, okay. So, while your n is greater than 0, you take r mod 10, and what will you now remove from 13 to 18? Remove everything till 18. Till 18. Yeah, this also. Yes. So, once you get the r, what will you add to the sum? Hit enter. The cube of the r, right? R cube. R into r into r. Semicolon. Right? And then after the loop finishes, you will compare the sum with the, after the loop finishes, what will you compare? The sum with the, yes. So if the backup, then you will say, yeah, you can just print that. And yeah, if you want, you can display. Why aren't we displaying n? Because why aren't we displaying n at line number 17? At line number 17, why aren't we displaying n? Why are we displaying backup? Why are we displaying n? Yes, n has become 0, correct? N has become 0, so we will not display n. Hmm. Got it? It is Armstrong number. Enter 154 and check. Enter 154 and check. Okay. Okay, now I want you to accept 5 numbers and show me which are Armstrong from them. So you'll put this entire logic in a loop which run 5 times, correct? So take a variable j, after sum take a variable j at line number 5 and comma, some comma j, and hit enter at the line number 5, hit end, go at the end and hit enter. At the line number 5 end, go at the end, enter, yeah. Now run a for loop which run 5 times with j. Use j as the for loop variable. Bracket after for. No, bracket after for. No. Put a bracket after for first. J equal to 1, semicolon. J less than equal to 5, 5 j plus plus, and put this whole thing in the bracket. Hit enter, yeah, and now close the bracket at line number 24. Closing bracket at line number 24. So one task, the task which you are doing once, we are doing it 5 times now. Okay, now run. So this same task will be repeated 5 times. So we'll ask you enter 5 numbers. So slash and it won't, because now it is in execution mode. Stop it and then run. So you know now what loop is doing? Loop is just iterating that task that many times. So now run it. It is give 307. It was 370. You know 370, 407. Okay. So now we are getting the numbers from the user, but this is done 5 times. Correct? Getting it? So now I want you to practice this thoroughly. These mod 10 divided by 10, how to work on our numbers, so you can work on your single digits. Getting this concept you're understanding, right? Yeah, save this for future reference, and